Hi guys, let's do a combustion analysis problem. Specifically, let's look at the one that was on that extra stoichiometry packet. And then I also am just going to add to this video and go through a few of those different types of reactions. I'm posting a key to the packet that I gave you today in class over the review. So I kind of wrote a little sloppy on it. Because it was just kind of for me, but I thought that maybe you would like to see some of the stuff kind of worked out so it's there, maybe what the answers are so much. So I will post that as well. Okay, on the packet it said, a combustion of 4 grams of a compound that contains only, so I have a 4-gram sample that has carbon, hydrogen, nitrogen, and bromine in it. It says that this particular combustion reaction will yield 3.826 grams of carbon dioxide, and I will yield 2.087 grams of water, okay? They also say that in another sample of the compound with a mass of 3.11 grams of all of these, like all of this particular compound, 1.803 grams is specifically bromine. My goal is to find the empirical formula of this compound. So, first things first, I need to find grams of carbon, grams of hydrogen, grams of nitrogen, grams of bromine. So let's start off with maybe what the easiest thing is. I have 3.826 grams of carbon dioxide. Let's take that to grams of carbon. So I could go from grams of carbon dioxide to moles of carbon dioxide. Then I can go to moles of carbon. And then I can go to grams of carbon. Right? Right. So I know that in 1 mole of carbon dioxide, there should be 44.01 grams of carbon dioxide. I know that in 1 mole of carbon dioxide, there's 1 mole of carbon. And then I know that in 1 mole of carbon, carbon will have a mass of 12.01. Okay, so if I do that math across, I should get 1.0, we've got 1.044 grams of carbon, okay? So I have grams of carbon. The next easiest one, I think, will be water. I'm going to do a very similar process like what we did here. So I'm going to go from grams of water to moles of water to moles of just a single hydrogen there, and then to grams of hydrogen. Moles of water, and then grams of water here. Okay, I know that in 1 mole of water, I have, is that 18 grams of water? In 1 mole of water, I have 2 moles, because of the 2 there, of hydrogen. And then in 1 mole of hydrogen, I know what, that's 1.008. So we'll do that there. Let's do my math here. So 2.087 times 2 18. So here I should get 0.2337 grams of hydrogen. Okay, I have carbon, I have hydrogen. I need to find nitrogen and I need to find bromine. In the problem, they told me I have another sample just like this that has carbon, hydrogen, nitrogen, and bromine in it. And that particular mass of that sample is 3.111 grams. I know specifically for this one that bromine takes up 1.803 grams of that sample. So I could find, because this compound should have the same empirical formula as this compound. So I know that bromine should be in the same ratio as the one that has the 4 grams. So if I did 1.083 grams over 3.11 grams and find a percentage, maybe, or the fractional abundance. So if I do that, we would get 1.803 divided by 3.11. So I get that to be 0.5796. So that means that bromine should be occupying 57.96% of this 4 gram sample. So let me do that. Let me take 4 grams times then that fractional abundance of 0.5796. And this is specifically giving me bromine here. This is my goal. So if I do that, we should get bromine then to have a mass of 2.318 grams. And that will be for bromine. Now I have 3 of the 4 pieces that I need. And I know the original mass of the sample. So I know bromine, I know hydrogen, I know carbon. So how about I take bromine's mass, hydrogen's mass, and carbon's mass, let's subtract it from 4, and then that will give me my mass of nitrogen, okay? So if I do that, we should get, what do we have, 4 minus then this big giant quantity of, it was 2.318. Yep, 2.318 with 1.044 with 0.2337. Okay, so I'm taking all of the ones that I found and subtracting it from 4. That should then give me the mass that nitrogen is in this sample. I should get that to be 0.4043 grams of nitrogen. Okay, so now that you have all of these pieces, it's just an empirical formula problem. I'm going to take my grams of nitrogen, take it to moles of nitrogen by dividing then by the mass of nitrogen. And then once I find all 4 of those individual things to moles, once I convert all the grams into moles, we know that we're going to divide by the smallest of those numbers, and we're doing that because we're setting then a whole number ratio. So I want one of those to be 1. Once I get that, that should give me then my empirical formula, hopefully if they're all whole integers. If not, then we may have to round or multiply by 2 or 3 if that's the case. You should get your answer to be C3H8NBr. This is what the answer should be, okay? But I at least got you to this point. Okay, I'm going to stop here because the bell just rang, but I will do another one and post another one with a couple of the reaction practice, okay?